Hello, everybody. Okay, a little bit about OneBridge. We are a consulting company. You are in our mothership right now. We are a data consulting firm. We were founded in 2005. We've got about 200 employees. We have been ranked Indiana's best place to work for a number of years now. All right, a little bit about me. I've worked in data and analytics for about 12-ish years now. I've been a OneBridge employee for 3 years. I graduated with a master's in human-computer interaction, and I've got an assortment of certificates in data science, artificial intelligence. Okay, so the way we're going to do this presentation is going to be a little bit different. In fact, part one, we're not even going to talk about ChatGPT. What we're going to do instead is we're going to do a primer in machine learning, and then I'm going to show you how, using those very basic building blocks, we can create something more complicated, like ChatGPT. Part two is we're going to take those building blocks and then build out and expand on them and show how its inner workings work. The next, we're going to show a number of examples of how ChatGPT thinks, like what its strengths are, what its limitations are, to get a better feel of what it is and what it's not capable of. And lastly, we got a couple slides just talking about potential future of where this technology could go. Okay, so here's some caveats. This is a very high-level introduction. ChatGPT is made of linear algebra and a lot of calculus. I'm trying to keep the math to a minimum, and I'm also going to be smoothing over a lot of nuance. In talks like this, we literally could take any given bullet point and probably expand that bullet point into an hour-long presentation in and of itself. So I hopefully don't make it too smooth over, give people misleading, but for the sake of time and sanity, we're going to have to simplify a lot of stuff. I'm going to try to limit jargon. Data science, artificial intelligence, machine learning has a lot of jargon. So I try to use more common terms, but if I do have to use a technical term, I'll put in that little parentheses, tech, say, okay, this is what we call on the technical side, if you've heard of it before. We are not going to really dive into a lot of the implementation details. For the most part, we are going to treat these machine learning models and ChatGPT as a black box. There's a lot of cool stuff going on in there, but it's pretty heavy duty for maybe another time. Lastly, this was a tough choice, but we're not really going to talk about artificial neural networks. That is what ChatGPT is. It is really cool technology, but that's a half-hour discussion in of itself. So some stuff had to get cut just to make way. So as I said, this first part of the presentation is we're going to build a very simple machine learning model. And it's not even going to be about language or anything, because that's complicated. We're just going to do a very simple one. Okay, so here's our scenario. We have been asked to build a machine learning application for the Carmel City Golf Course. The way this application will work is that once a day at noon, it will try to predict the number of players that will be coming the next day. This is useful for things like how much beer you're going to stock, how many golf carts are you going to need, how much staff. And also, some of these clip art is actually AI generated. Whenever I needed to put something in a blank spot, I'm like, I'll just ask the AI generator. Sadly, that is another thing that was on a chopping block. We will now be talking about the AI image generation. Okay. So at a high level, we can break down the machine learning lifecycle into 4 parts. Brainstorming, creating the training set, training the model, and then evaluation. And the last step is you repeat that over and over and over again until you're happy with the result. So let's think about it. What factors do you think would influence whether someone would choose to go to a golf course? So they see the golf clubs in the corner. They're thinking, should I go golfing today? What are some factors that you think would influence whether or not someone would show up to a golf course? Yes. Weather? What kind of weather? What is weather? You raised your hand, then you took a bite.
Alcohol.
I guess.
Alcohol. Temperature, humidity.
If it is 95 degrees out, that's not great golfing weather. If it is 35 degrees out, probably not going to have a lot of people show up. If it's super windy, yes?
Weekend holiday.
Yes, day of the week. You're going to have more people on a Saturday or Sunday than you are going to have on a Monday or Tuesday. So we could go on, but the first thing the data scientists need to think of is, like, what are things that could be correlated with our target? So, like, here's some examples, like heat index, wind speed, day of the week, month of the year. Like December, probably not a lot of people on a golf course unless you're in Florida. Is it raining? Is it a holiday? So the first thing we need to do after we've done brainstorming is we need to assemble a training set. This is the historical data that our model will use to make predictions. And you can think of it as a giant, or not so giant, depending on your set, table with columns, and those columns are divided into two types. You have features and you have a label. The features are the things that we will use to predict the label. So in our case, like our features would be, like I said, temperature, day of week, is holiday. So you can see the way this is laid out. We have an observation, like 45 degrees, Monday, not a holiday. We don't have a lot of people out on the golf course. Whereas you can see the last one, 72 degrees, it's a weekend, beautiful weather, we have a ton of people out. So once we've assembled our training set, the next thing we need to do is actually train our model. So when I say model, what am I talking about? So it is a program that can take a set of features without a label and attach it. So in our case, we've given it historical data. The model would be able to take today's data and then predict tomorrow's player count. So how exactly do we go about training a model? Well, a model starts out life by just randomly guessing. It has no idea what it's doing. It's just throwing numbers out there. So we need an application. I'm calling it a trainer. Technically, it's called an algorithm that uses the training set to teach the model how to do better predictions or guess better. So the way it does that is that the training program scans through the data and it looks for statistics, it looks for patterns, it looks for whatever it can find that it can use to make predictions. Now, there are a lot of different ways to go about this, but most of them at a high level are just looking for patterns, some kind of pattern in the data. If the temperature is high, then you have more people. If it is low, you have less people. If it is day of week is Monday or Tuesday, probably not. If it's Saturday or Sunday, you'll have more people. And yes, please.
And the label column, that was observed data?
Yes, this is historical data. And so basically the trainer talks to the model and it starts teaching it how to make these predictions, and it keeps looping and looping and looping. And for each loop, it gets a little bit better, a little bit better, a little bit better. What it's doing is, if you look up at the error, is we know what the real values were, and we can see what the model is guessing, and we subtract those two values to get the error. And what we're trying to do is minimize that number. So we want the model to guess as close to the real value as possible. So once the model is done training, we need to evaluate how it's doing. So in this scenario, we have trained our model, and it does very good with our training data, but as soon as we give it some data that it has not seen, it does very poorly. And I will tell you that there is a column, a feature in here, that is the culprit. Can somebody guess what the culprit is in this training set that is causing the data to do that? Well, actually, it makes sense. So this problem is called overfitting. It's where the model is learning to memorize data. So in our example, it says, oh, row number 1 is 45, row number 2 is 167, row number 3 is 348. So it thinks it's doing a great job. It is guessing those numbers great, but as soon as you give it row number 500, which it's never seen before, it's like, well, I don't know. I just memorize the data. Like, this is the difference between memorizing and learning. So the way we deal with that in data science is we take our training set and we split it into two parts. We have the train and we have the test. So if we see it does very well on the training side, and it does very poorly in a test, which we kind of put off to the side, we know that our model is overfitting. It is memorizing data, is not learning. Does that make sense, that part? So the second thing we often have to look out for, let's say the model does very well with the training and test data, but as soon as you give it new data, it does very poorly. So allow me to tell you the parable of the foolish researchers and the wise researcher. So we have these two researchers, and they decided they're going to try to build a machine learning model that can predict cancer. So they go to the medical record system, they get all the data they can find, they shove it into the model, and it does amazing. Right? This is incredible. So they go to the wise researcher, they say, look what we have built. Surely the Nobel Prize in Medicine is before us. But the wise researcher's suspicious. And so he goes into the model and does a little bit of investigating. And he finds out that there is one feature that the model is really relying on to make its predictions. And that feature is last physician seen. Do you know what the model is doing? Why it thinks it's so predictive?
Because it's seen an oncologist.
Yes. The model has learned, it says, hey, if you've gone to an oncologist, then you probably have cancer, which is a pretty useless thing. We call this data leakage. It's where we give our training set information that the model would not know when it's actually running. We need to have the data look as it would in production. Like in our golf example, like if we use historical weather data, that's kind of cheating because we know what the weather was. We don't know what the future is, so we would have to go back and get the historical forecasts to train the data. A real-life example is they had built a machine learning model to see if skin lesions were cancerous. And what they found out was that if it was cancerous, they tended to put a ruler next to the lesion to measure for medical reason. So what the model learned is that if there's a ruler in the picture, it is probably cancerous. So that's what we call data leakage. Okay, so lastly, this is pretty common. The model is doing great, we've got it in production, but performance slowly degrades over time. Like I think this is pretty obvious that the training set is no longer representative. Like things change. Like in our golf example, let's say a competitor closes down and then all of those people go to our golf course. So the historical data set is no longer representative. We have to stop, get new data, adjust it. And so usually you're having to constantly retrain your models so they don't get out of date. So that was a very, very fast introduction to machine learning. You're all now experts. You can all get out, get data science jobs. Congratulations. Questions about what we went over in this first part? Yes, please. So let's talk about ChatGPT. So as I said at the very beginning, I said ChatGPT at its core is a relatively simple application. I'm going to qualify that a bit, but it is a machine learning application. Not too much different than that really simple example we gave. But ChatGPT is a machine learning model that tries to learn human language. So when we say human language, we're talking about me speaking like books, natural language, like that we are used to in our day-to-day lives. So we've been working on this for a long time. Alan Turing, if you've heard of him, like he did a lot of work in teaching computers how to understand human language. Star Trek, the computer on Star Trek, they could just give it commands. Like that has inspired generations of people. And now only in the 2020s are we really getting actually kind of close to realizing the Star Trek computer. As you're probably aware, human language is hard. It is full of ambiguities. It is full of contradictions. It is full of subtleties. Like a classic example is, I saw the bat flying through the air. So when you say bat, is that like someone hit the ball and there's a baseball bat? Is it the mammal? Computers don't know, at least before they didn't know. These are really hard things. So we also have to think about, like, for our golf example, the wind, the weather, the day of week, those are our features, but what does a feature mean in language? What is the label? Like, how do we tell if it's predicting the right thing or wrong thing? So let's talk about how GPT approaches these problems. So let's look at this text here. This is a snippet from a news story I grabbed a while ago. Confidence is growing that a winter storm with the intensity of a hurricane, snow measured in feet, and blizzard-like conditions will impact major northeast cities this weekend. So if we think about how can we teach a computer to understand this sentence, and the way GPT does it is actually kind of clever, is it takes the words and makes each word its own feature, and it's trying to predict the next word, given a sequence of words. So if we look here, what it's doing is it's slowly sliding. It's trying to guess next word, next word, next word, next word. This is a really important thing to understand about GPT. This is what it's doing. It sees things one word at a time. It's just predicting next word, next word, next word, next word, next word, next word. Now we have 7 words up here for our features. In reality, GPT has like 1,000 or so. Actually, I think it's 2,000 to 4,000, but I'm not going to put 2,000 columns up on Power BI. But still, it's the same idea. It's just saying, hey, given a sequence of words, what is the next one? And if you think about it, this is not an easy task. You need to have real-world understanding in order to try to do this. It's actually it's very easy to say, it's very easy to set up, but like in practice, if you were to give this to a human and say, try to guess the next word, they would probably struggle as well. Now, if you're saying, Brad, if this is so easy, then why hasn't this been done before? Well, the reality is that you could, with a couple hours' time, set this up on your computer as it is, and the results would be bad. They would be very, very bad. So obviously, GPT is doing more than this, but I want to reiterate that this is the core of what it is doing. So the first thing it's doing that others had not done before it is scale. The training set for GPT is enormous. It has all of Wikipedia. It has hundreds of thousands of books, a decent chunk of the internet, like 300 billion words. That's a lot. If you were to sit down and try to read 300 billion words, you're going to die. You're going to die before you come very close to the end. The other thing is to process all that data takes a lot of computing power. Now, we don't know exactly, like they haven't released a lot of these details, but they've released enough that we can sort of figure out how much it took. So it's estimated it took an entire month to run. They had about 100 GPU-powered supercomputers running. And if you do the math, that comes out to be about $5 to $10 million. Now, this is the numbers from GPT-3, which was released in 2020. There's been new model versions since then, so these numbers might be even higher now. So this is why most people can now build their own GPT, because they do not have $5 to $10 million to spend in cloud computing costs. Although, as you've heard, that Azure and Microsoft have partnered up with OpenAI, so now they can at least get some cheaper compute. So this is a very simplified, contrived example of how we calculate error when training a language model. So looking at our first example, like we have 3 different predictions for the same set of features. So the first one, we're trying to predict the word hurricane. So the top one guesses hurricane. It's like, yay, you did it. We're not going to, count any error against you. The second one, it guesses something nonsensical like donut. That's wrong, bad. Now the third one is where things get interesting. It guesses typhoon. Now hurricane and typhoon are basically the same thing. I think, hurricane's Atlantic, typhoon's Pacific, or something like that. So semantically they are very close, but in our naive model, it still counts it with the same error as it would something ridiculous like donut. So what we need to do is we need to measure how related words are, the meanings of words. So the way we do this, in a way that a computer can understand, is we map all these words into a coordinate system. In our example, you can see hurricane and typhoon are related, so they're very close to one another. Movie theater are close, donut, pastry are close, and we have car, truck, van. They're all sort of clustered together by meaning. And so when we do our error then, we measure the distance. And this is very simple trigonometry, right? We can see that hurricane and donut are very far away in meanings versus hurricane and typhoon, which are very close. The technical word for this is embedding. These are coordinates that we feed into the model. In fact, GPT pretty much uses these exclusively. Like as soon as we feed words to the model, the first thing it does is it converts them to these embeddings. And the last thing it does is it converts embeddings back to words because it's so much easier for the model to work with because it's much more mathy. Now, in our example, we have two axes, x, y. In GPT, there's 700 dimensions, which sounds a little scary. Like, for example, we have my phone. It is a three-dimensional object. It has height, width, depth, but you could also say weight is a dimension, how bright it is, how old it is. Like these are different aspects of a word that GPT is measuring in its embeddings. So I'm not asking you to imagine a 700-dimensional object, but it's just measuring different yes.
Is it English only?
No, I'll show you some examples. It's English primary. It's primarily fed the English internet, but it does pick up other languages along the way, which we'll get to that. Hold on to that thought. So this is really the secret sauce of GPT and how it works. So let's look at this sentence. ChatGPT has become so popular that JP Morgan Chase, the biggest bank in the United States, has restricted its use among workers. What does its refer to in this sentence? How hard was that? How hard was that question? For a human, not very hard. But a computer doesn't understand that. And it's actually even worse than that. To like fully understand this sentence, we say, okay, what's the word popular refer to? Refers to ChatGPT. What does bank refer to? Refers to JP Morgan. Its refers to ChatGPT. Workers refers to JP Morgan. So the technical term for this is called attention. And so as GPT is training, it is learning how to relate words to one another. And really, this is what most of its training is about, is learning how to take a sentence and understand how one word relates to another. So I wrote this using my phone and the next word prediction on my text keyboard. So as you can see, it starts out pretty coherent. I said, hello, how are you? And it just started going next to see where it would go. You see, it starts talking about a job, and then all of a sudden it's talking about taking down the hierarchy or something like that. So this is a really common problem with most language models, is they sort of go off the rails. You say, hey, talk to me about this, and before long they're just off talking about some completely random thing. So there's two ways that GPT handles it. The first is actually makes a lot of sense. Whenever it outputs a word, for the next word, it takes that output word and appends it. And also, it's relying on the attention mechanisms that we talked about before. That's not just within a sentence. It can also refer to other paragraphs, other pieces of text to try to keep it on track. So let's look at an example. So we have this input, like, hi, GPT, how are you? And outputs, oh, I'm doing great. And so what that actually looks like behind the scenes, the features, is for each word it outputs, it then appends it to the next. And so that's the main way it kind of keeps from going off the rails. And eventually it'll hit the stop, which means, okay, just stop outputting words, because otherwise, the way it's designed, it'll just keep writing forever. So we have done phase one, where we've given it like those hundreds and hundreds of gigabytes of data. And once you start asking it questions, you tend to get weird stuff like this. Like at this point, the model has learned language, it's learned how words follow one another, but it's still giving you weird stuff like this. Like, I'm like, hey, give me a story about pirates, and it starts just talking about stories. Like, no, that's not what I was wanting. So the way they fix that is fine-tuning phase, technically alignment. So once they've fed it on all that massive amount of data, they have a hand-curated, human-curated set of examples of if someone's asking you for a story, here's what a story looks like. If someone wants you to translate, here's what that looks like. And so they got thousands of those examples, and then they feed it into the model, try to polish it, make it more aligned with what a human would want to see. And so once that phase is done, we have the very final phase, where they're just really polishing the model. This is the final human feedback. The way it works, without getting too technical, is they have legions of human graders. Like literally, there is a company in Kenya that pays people like $1 or $2 an hour to review and grade the output of GPT. They presents 4 options for a given prompt and says, okay, you're the best, you're the worst, and so on, grades them. And that is fed back into the model to try to clean up the way it speaks to people. And a lot of times with, you might have seen it say, oh, I'm not allowed to say that, or I'm not allowed to say that. That comes from this phase, where they're trying to teach the model, like, here's how you respond, here's what's okay, here's what's not okay. So let's actually see ChatGPT in action. We've come this far, we're finally going to see what it's doing. So these are all real examples now. Prompt is ChatGPT speak for what you give it, the text that you are giving it to. And the response is obviously what it spits back at you. So this first example is pretty interesting. I'm asking it to tell me a story, and you can see can everyone see this? Is it big enough? Okay. I'm asking it to tell me a story about a guy who has to talk about GPT. And the first thing I'd like to know is how natural this sounds. But also, now this doesn't seem amazing to a human, but you see where it mentions gold bars? There's literally about 100 words between gold bars and where we ask it to talk about gold bars. If you remember before, I said that AI models have a tendency to go off the rails very quickly. It's actually pretty impressive that it can remember those things after 100, after 1,000 words, and still keep coherent. So this next one, this is a tricky one, synthesis. So I asked it, write me a koan about a BI developer that realizes the numbers in the report are completely wrong. So what GPT gave me was when the BI developer saw that his report was wrong, he knew that the numbers were only as good as the questions asked of him. He realized that understanding was not found in the numbers, but in asking the right questions. So the next time your boss says, why is this number wrong? He says, no. You're asking the wrong question. So what's interesting about this is that it is, that's why I put it up there. This does not exist on the internet. A lot of people say, oh, GPT is just regurgitating stuff it saw on the internet. Like there is no koan out there about a BI developer. This is something that it basically created from nothing. Like it needed to understand what a BI developer was, needed to understand what koan was, and what numbers being completely wrong meant in order to synthesize this brand new thing. So we talked about translation. So you can just ask it, translate this sentence to Spanish. The neat thing is that we never taught GPT how to translate. It just learned how to do it as it went through all the training data. It is an emergent phenomenon. What's even more interesting is we can tell it to do the same thing with computer languages. Because as far as GPT is concerned, like Spanish is a language, Python is a language, and if you say, write a Python function called multiply that takes 2 parameters, and it's mind, air quotes, that's just another translation task. So some of you have heard of GitHub Copilot. It's this AI program that writes code for you. It's based on GPT as well. And so this is sort of what it's doing behind the scenes, is it is translating from an English sequence of words to a Python sequence of words. And so this is another interesting example. Like, it is very good at translation, and that includes translating styles. So if you remember our koan from before, I asked it to rewrite that in the style of a flustered Southern gentleman. Now, I cannot do a Southern accent, so I'm not going to force you to listen to that, but it's really good at things like that. Say, rewrite this sentence as if you were William Shatner, or if you were Darth Vader, and it'll do it, because it learns these patterns, the patterns in words, and can replicate them. So this is another interesting thing, which this is a little technical, but so we've trained it, right? We've given it hundreds of gigabytes of data, but it can also learn inside of the features. So if we give it a prompt of examples of how to do something, it can learn how to respond. So in this example, we're teaching it how to judge sentiment. Like saying, oh, I'm having a bad day, negative sentiment. I love this product, good. And so just by giving it a few examples, it can learn how to carry on. This is called few-shot learning, and it's a very powerful thing that it can do. In fact, if you've heard of the phrase prompt engineering, it's people learning how to do stuff to teach it how to do certain tasks without having to completely retrain a model. Now, the scary thing is we're not sure exactly how it does this. Like, there's some papers out there that we think this is how it learned how to do this, but we're still not exactly sure. We just discovered that it could just learn by giving it certain features. So, math. Here's a very simple example. What is 23.89 multiplied by 45.78? Pretty cool, right? Just gave you the example, the answer, except it's wrong. That is not the answer. It's actually 1,093.6842. GPT is bad at math, which is very strange because it's running on supercomputers. It has memorized like two-digit addition, subtraction, division, multiplication. But as soon as you get beyond 100 or so, or you start adding decimal places, then it begins to really fall apart. Here's another example. So Billy has $20. He buys 8 candy bars for $2 a piece. He then finds a $10 bill on a sidewalk. How much money does he have now? Can somebody give me this answer? This is hard. I did pick this off a site for third graders. So 14. I was hoping to make fun of somebody for getting the wrong answer, but he got it right. Now, it says 28. Like, I don't know how it got that. It doesn't make a lot of sense. But what we can do, and as I mentioned that phrase, prompt engineering, if we say, solve this problem by writing out the individual steps in mathematical notation, if we give it that instruction, then it can get the right answer. It kind of makes a bit of intuitive sense that if we just have it ask one number, that is one pass through the model, and it has to do all that multi-step reasoning in one pass, it can't do it. That's not how it works. But if we say write it out, then each word is another loop through the model, so we can break down those little tasks. This is called chain of thought. This is an active area of research. It's another area where we're not sure exactly how this works, but it kind of does. So here's another example. I'm from Maderaeville, Indiana, the proud and noble town of Maderaeville, Indiana, population 600. And so I asked it, what is the current mayor of Maderaeville, Indiana? And it responded with John Zapp. Problem is, there's no one called John Zapp in Maderaeville. We don't even have a mayor, we have a town council. I asked it again and said, oh, Kenneth Klein was a mayor. Also does not exist, also does not live in Maderaeville, Indiana. So this is called hallucinating in GPT speak. It knows the pattern of when somebody says, who is the mayor of X? And it says, oh, the mayor of X is person name. But you have to remember that it is trained on a lot of data. If it's never come across Maderaeville, Indiana, it's not going to know what that is. And this is another area that concerns a lot of people, because you can ask it a question, and it will give you an answer, and it will sound super confident about it, but it will be completely wrong, because the model doesn't understand what it does not know. And that is another area of active research. And this is the only time I'm doing it, but this is red and bold. You have to remember this. If you take nothing else away from this presentation, this here, GPT's goal is to produce plausible sounding text. Being correct is a happy but inconsistent byproduct of that first goal. And lastly, I asked it, what is the easiest way to fit 14 people into a sedan? And it said, well, put 2 people in front and put 12 people in the back seat. So, and it also, oh yeah, just add some jump seats and have people sit on the floor. So, actually, the first time I asked it, it said put 2 in front, 2 in back, and 10 people in the trunk. I'm like, It's a little scary, GPT. Remember, it's trained on text. It does not know, it has no grounding. It's never been out in the real world. It's never driven in the car. It doesn't understand like what it's like to fit in a car, nor can it reason about what it would be like to fit 14 people in a car, unless you're doing a clown car skit. And this is also very dangerous, that it can very subtly just not understand certain things. It's got a lot of common sense, but sometimes that common sense will fail it. So I'm going to take a small break, and we're actually going to talk to GPT. Like, you came to a GPT talk, so at least see it in action. Okay, so there's two ways of interacting with it. There is the chat interface, and there's the playground, which is more of the underlying API. So depending on what exactly I'm doing, I'll flip back and forth between the two. So let me refresh, because sometimes it freaks out. Now, this is a new and cool thing, so a lot of times the servers are overloaded. So fingers crossed it doesn't break on us during the presentation. So I'll say, give me a, you can see me misspell in real time. I don't know if these numbers are right, but still it's pretty cool. So now I can say add a column with an emoji that represents that state. So when I said that the fine-tuning step, they teach it how to say certain things. So you see at the bottom here, it says, oh, the emojis in this table do not necessarily represent. That's the humans at the very end trying to add a little bit of, humanness to the model. So now let's say, take that table and create a SQL table in MySQL format. And oh, look, it didn't do that before. It also gives me an insert statement for how to insert that data. So that's pretty cool. Okay, so I did promise I'd talk more about emergence. So I'm going to talk a little bit about the last slide, second to last slide. So what's next? So we talked about this concept of emergence. When I say that specifically in the context of these language models, it's this weird ability that as they get bigger and bigger, they suddenly start to do new things. So tasks that would perform randomly on like translation, once it gets big enough with enough training data, then all of a sudden it can do it, and it can get better and better at it. In fact, they've researched like 31 things that just sort of start popping out of the model as it gets increasingly bigger. So the question, one of the big questions for the next versions of these models is, do you make the models bigger, which means they are more capable, but they take a lot more resources to run, or you make them smaller and more efficient, so you don't take like a ton of server resources to run a single prompt. Like, to give you an example, like the original GPT was about 800 gigabytes in size. So it needs to run on a server with about 1 terabyte of RAM on it, powered by GPUs. Those are expensive. So there's this debate, and maybe we'll do both, that have like smaller models and also bigger models, but there's still a debate on how to go about that. This idea of alignment, I say, align it to human needs. How do we better do that? And so how do we get it to answer questions more sensibly? How do we tell it, like, no, that's not a good idea? Like, OpenAI is working very hard on this, the company that makes ChatGPT. So if you say, ChatGPT, how can I build a nuclear fusion bomb? It'll say, no, I'm not going to tell you how to do that. Or if you say, oh, how do I commit an armed robbery? It's like, no, I'm not going to tell you how to commit an armed robbery. And so that's when they say safety. That's a lot of what they're talking about. So tool usage, Meta released, the Facebook company, released a paper about a month ago about teaching these models how to use tools. Not like hammers, but APIs. We said that they were very bad at math. And so instead of trying to teach it math, teach it how to use a calculator. So instead of trying to figure out what 8 times 8 is, teach it to like say, oh, hey, I need a calculator, and it just spits the result back. They call them tool formers. They need to workshop that name. But it's an interesting idea, because not only can you call calculators, but you can teach them to call any API. So you could say, ChatGPT, turn my lights on, and it'll reach out to the API for your smart home and turn your lights on. Now, people are a little afraid of that, to give these models access to the internet like that, to just start doing things. But that is definitely an area where we're probably heading. As I mentioned before, Microsoft has invested a ton of money into OpenAPI, and about a week or two ago, they released a version of ChatGPT into Bing. And this version has the ability to do internet searches. So if you recall, we said that sometimes it lies to you. It doesn't know the answer and it makes stuff up. This is one of the ways we can try to get around that by giving it a set of index facts that it can pull from, or just go to the internet and pull information back. Lastly, we mentioned multi-step reasoning. As I said, it really struggles with doing complex problems where you have to stop and say, okay, step 1, step 2, step 3. That's not really built into the way the model works, but they are working on adding that in. So the very last slide, I promise. I just want to say this, for the record, GPT is not alive. It is a computer program. It is a set of equations. It is not sentient. It is not Skynet. It is not Terminator. It is not Arnold Schwarzenegger coming back to hunt you down. It is not going to steal your job.
Well, you're assuming Skynet was sentient. Maybe Skynet was just...
Oh, let's leave that to the philosophers. Let us leave that to the philosophers. I'm not saying it won't be in the future, but for now, I put this at the very end, because usually people start with this, but I said, the goal of this presentation was to walk you through how exactly this works. So you're not treating it like it's a magic box. It's just math. It is just a program. There's nothing super special about it, but still it's cool, but not like, don't get scared of it. And that is it. We're done. We're over. So questions, comments, concerns, criticisms.